Hi friends, hope you are doing well. I'm Dr. Ganguly. Welcome to my channel. So today I'm going to discuss about the different type of engineering departments, and this is a question from a viewer, and of course this is a very important question because you want to exactly know if you are taking the right department based on your own capabilities, your own strengths, and so on. So let's discuss this problem in quite detail. So we are going to do a deep dive today on this particular problem. Now, if we look at the way the engineering departments came up, essentially at the beginning there were only two engineering departments, and these were civil engineering and military engineering. And as you can understand, civil engineering dealt with all the different things which are constructed for civilian infrastructure. For example, they are roads, they are buildings, they are ports, and so on. And military engineering dealt with all the things which are required for a military campaigns, such as these could be ships, these could be the tanks, these could be the cannons, the guns, and so on. So essentially this was the way the engineering department started, and later on there was a bifurcation based on the different needs which were there in any given society. So let's discuss all these departments in detail. Now, in each case, I'm going to also tell you what are the branches of physics, chemistry, math, or bio which are important for any of these departments, so you will know that where your strengths lie. So let's start with the civil engineering department, which is one of the first departments which came up. Now, whenever you think of civil engineering, you always think of things such as buildings, dams, roads, airports, ports, stations, factories, power plants, and so on. And all these things have to do with civil engineering. They have to do with urban infrastructure and so on. Now, the core disciplines as far as civil engineering is concerned are solid mechanics, statics and dynamics, fluid mechanics, and also the study of different type of materials such as concrete, steel, cement, and construction. They also do a lot of work on the soil itself, on surveying methods, and so on. Now, if you go back to physics, chemistry, and math, you will think that as far as physics are concerned, mechanics is going to be more important. As far as math is concerned, calculus and differential equations is going to be most important because there is going to be a lot of modeling involved here. And in terms of chemistry, anything to do with modeling the different type of materials which are used in civil engineering, that's going to be important, whether it is cement, whether it's concrete, and so on. So these are essentially heterogeneous materials, so you need to study about them. Now, very often concepts of probability and stochastic processes are also important because a lot of reliability goes into civil engineering. You may even need to do earthquake engineering and so on. So you need to make sure that any buildings, bridges, or railway stations you are designing are not those which are damaged in case there is any earthquake, there is any other natural disaster. So the study of natural disasters itself is an important part of civil engineering. Now, recently the environmental engineering departments have come up because people have realized that sustainability is also very important, and some of these departments also feed into the civil engineering framework. Now, if we look at the next important engineering branch, it is mechanical engineering. And whenever you think of mechanical, you think of things such as cars, trucks, trains, locomotives, steam and gas turbines, marine turbines, ships, even aircraft, different type of machines, robots, helicopters, and so on. Now, you can actually think of aerospace engineering as being a subset of this department, and aerospace took off as a separate department because a lot of growth happened in the aerospace industry in some countries, and so people felt that there was a need for engineers specially trained in this area. Because do remember that in mechanical you may spend a lot of time studying things such as boilers, such as steam, such as steel as a material, but as far as aerospace is concerned, you are mostly concerned with the different type of materials which are lightweight, such as aluminum, such as composites, and also you may be interested in the air rather than in the water. So air has different characteristics, and therefore the science of aerodynamics becomes very important, but that can be considered to be a subset of fluid mechanics. Now, if we look at physics, chemistry, math, we will clearly see in physics, mechanics is of course the mother science here. You also need to know a lot about thermodynamics because heat transfer often becomes important in this area. And in mathematics, because of the presence of modeling, you need to know calculus, you need to know differential equations. If you want to study control in this department, then you also need to study matrix theory. Also, if you want to study robotics, then a lot of matrix theory and differential equations and transformations may all get combined together. Now, chemistry, of course, comes in here through the materials, through the thermodynamics, and so on. And of course, all the materials can be considered to be a part of mechanical engineering in some way, though very often there is a separate department called material science or metallurgy, which looks at the different materials, because that itself is a pretty big problem. So very often you will use some kind of metals in all this construction work, and therefore you need to know things about them, but mechanical engineers mostly consider the mechanics of the materials rather than the intrinsic nature and the construction or design of these materials. Now let us look at the next department, and that is electrical engineering. And as far as electrical engineers are concerned, they often look at circuits. Whenever you think of electrical engineers, you think of currents and resistance and capacitors and so on. So these guys deal with different things related to magnetism, electromagnetism, generators, power systems, electricity, electronics, computers, transistors, semiconductors, wireless internet, the wireless system as such, avionics also in aircraft and cars. So nowadays what has happened, that if you think of any aircraft or a car, you will actually realize that most of the cost of these vehicles is in the electronic system. So electronics has become very important over the years. Now, in terms of the branches, you need to understand these subjects. In physics, you would of course need to be good in electrical circuits and also in the magnetism and electromagnetism parts of the syllabus. So whether it's Maxwell equations or any of those different things, you need to know that. Also, optics will come in handy. In mathematics, you need to know calculus, you need to know matrix theory, you need to also know certain methods such as Laplace transform and Fourier transform. So very often the electrical engineers deal a lot with transforms, and therefore this is a different type of mathematics. Complex numbers become very handy here. So electrical engineers typically often use j instead of I, where I or j is root of -1. Now as far as materials are concerned, materials is not so important here, but of course you have to remember that all these things are made of some kind of material. So for example, semiconductors would be made of some material. You would need to know the different things about silicon and so on, and therefore material knowledge is always useful, but materials itself is studied by material scientists. Now do remember that in any company what happens is that there are different branches, and so there are all kind of engineers present there, and so they form a group which addresses all these problems. Now one thing to keep in mind is that most of the machines you see today are a combination of electrical and mechanical systems. So we can say that most of these machines are electromechanical systems. So if we think of a laser printer, of a fan in your room, of an air conditioner, of a refrigerator, of a washing machine, these are essentially electromagnetic or other electromechanical systems. So you need to keep that in mind. Now the next branch is computer science, and this is somewhat of an outlier because in some ways computer science is not really a branch of engineering, but unfortunately or fortunately it has been thrown into engineering for many systems and for many universities. Now computer science comes out more from mathematics here. The mathematics which you have is somewhat different. You need to know about logic, you need to know discrete math, predicate calculus, and so on. And also what happens here is that you need to know a lot about programming. So I would say computer science is somewhat detached from the physical world. It exists in the mathematical world, and what becomes important here is programming languages, the mathematics which is more related to discrete systems, because computers think in terms of bits and bytes. They convert everything into this form and then use it. And of course, if you are somebody who is interested in machine learning, some of the old math is coming back. So if you look at machine learning or deep learning books, you will see there is a plethora of calculus out there and linear algebra. So these have become important, as of course numerical methods. Numerical methods are important in almost all disciplines, and the bedrock of numerical methods is typically knowledge of calculus and differential equations and somewhat different type of thinking which comes in numerical methods itself. Now if we look at the next branch, we look at chemical engineering, and chemical engineers deal with a lot of very important things in life. So these could be fertilizers, plastics, different type of chemicals, for example petroleum, diesel, kerosene, and so on, detergents, soaps, paper. And so you can see that chemical engineering is extremely important in any country in terms of the infrastructure, in terms of the different things which you buy anywhere in a supermarket and so on. They are very likely to have been produced by some chemical factory. Now Here the key discipline is of course going to be chemistry, so the materials and how they are produced, the processes are going to be there, because chemicals are ultimately materials of some kind and they are formed through some kind of chemical reaction. So this is the field which is closest to chemistry. Now in terms of math, chemical engineers use a lot of math, particularly in process control. So you need to know things about differential equations, you need to know about optimization, linear programming, and so on. And also some elements of partial differential equations are required in most of these fields. Now if we look at chemical engineering, people also study a lot about fluid mechanics in this discipline. So flow through pipes and all may be there, and a lot of biology is also penetrating into chemical engineering, because many of the newer ingredients which are out there have a biological component also. So that's something to remember. Now the next field is material science and engineering, and like I mentioned before, they started out in the metallurgy department. So people used to study steel, people used to study the alloys of steel or related to steel and so on. And then there are different things such as aluminum, such as titanium, which are used in certain systems. People used to study them. But what happened is that there was a growth of material science enormously, and various kind of composite materials also came out. Not only composites where the plastics are reinforced with something like graphite, but also metal matrix composites and so on. So material science is pretty deep. It actually looks at the design of materials, why materials are a certain way, and so on. So there are two real components in material science. That is the experimental part, and there is also the computational and theoretical part, which is nowadays known as computational material science, and this is booming very much. People are even trying to bring in optimization and machine learning into the design of new materials. Now the next field is bioengineering, or sometimes biomedical engineering, which would be a subset of bioengineering. And this has come up because what people have done is that they have started realizing that biological systems are very important. So for example, you have various devices which are out there. You may have people with pacemakers, you may have problems related to body which can be solved through some engineering mechanism and so on. So you have prosthetic devices, you have things related to dental implants, and you may even have people who are actually trying to model different parts of the body. So there are people who are modeling the liver, who are modeling the heart, who are modeling the brain, who are modeling blood flow through the system, and so on. Now of course you will realize that modeling anything would require you to know the basics of mechanical engineering. So some of this bioengineering stuff can be done in mechanical departments, but some of it would also require you to know things about electrical or electronics engineering. So again, it is a multidisciplinary discipline, and based on your predilection you can choose the type of subject you want to study here. Now of course, like I mentioned before, a huge amount of interaction is taking place between these different departments. At the baseline of it, I would say electrical and mechanical are something which are the core of all departments, because most of the actual systems, machines which are out there, whether you take a modern electric car or you take an aircraft, they are actually electromechanical systems. So these two departments are going to be very important. The civil engineering department is extremely important, especially for countries which are growing rapidly, because a lot of infrastructure needs to be conducted. People who are living in the slums may need to be given proper homes. People who are living in homes need to get better homes, and so on. A lot of airports have to be made, a lot of roads have to be made, and so on. And also I would say that computer science starts becoming more important in highly developed countries, because what happens here is that most of the infrastructure work has been done, and so most of the action is in the computer side of the equation. So if you look at a country such as US, you will see all the top countries are in the computer science type of thing. So if you look at Google, if you look at Meta, you look at Netflix, all these guys are essentially selling bits and bytes and manipulating bits and bytes. They're not really making any product. So that's something also which is happening. And so you need to make sure as to what are your particular predilections, what are your particular strength in high school, so that you exactly know what you want to do. Now I didn't mention anything about the type of salaries you can expect here, because what happens is that salaries you can expect will depend to a large extent on the country you are in, because depending on the country you are in, the supply and the demand situation, the profitability of the industry you are in, you are going to make more money or less money. So I hope this video will help you in figuring out which is the appropriate branch. If you have any particular feedback about what branch you think is important, please let me know in the comment section below, and I will see you in a video sometime soon. See you then.